see, we've already done this. All I see is this and this. All right? Now, we're going to talk about converting potential to kinetic and kinetic to potential energy. If you understood what we did in the lab yesterday with the tennis ball, then this should be pretty easy, which is why I let you earn partial credit, or extra credit rather, on the quiz today. Because those of you who understood the tennis ball lab, I flipped through some of those. Some of them look great. Some of them are an unmitigated disaster. I haven't graded it. I just flipped through it, got discouraged, and quit. Laid it off to the side. All right, so in your circle, or what you need to write down. Okay, we're going to talk about energy conversions today. Potential to kinetic and kinetic to potential. We're going to look at about 3 examples, and then we're going to do a lab with this. That's a simulation on the computer. Because again, I can't provide you with a roller coaster.
Right. DIY.
No, we're really not going to make a roller coaster. No, we're not. Not today. All right. Does everybody have what they need? Hurry it up. We're going to draw a picture. We're going to learn to label.
Or KE.
No.
Blue, color, and a gold, and something to make it red.
All right, so I'm not waiting. Now, if we look at, if we have something rolling down a hill, which was what you had on the quiz, that I allowed you to earn part or extra credit on, you have to be able to label, all right, where on any picture or diagram you would have maximum potential. I'm just going to write P. I don't have to make it. Maximum potential energy. When you did the lab for the tennis ball yesterday, where was the greatest potential energy found? All right, first of all, potential energy has nothing to do with being thrown. Potential energy is strictly about height. Where is the greatest height? At the very top. At the very top. So, maximum potential energy is always at the most height. So, Marco. So all you have to find is whatever part of the picture has the greatest or the most height. Now, if you want to find the maximum kinetic energy, what did you do yesterday to give it the most kinetic energy? You threw it, all right? So you're looking for where it's going the fastest. So where in the picture, where will it always be going the fastest? When it's going down. So where it's going down would be the fastest? At the bottom. It's always the fastest at the bottom. So it's always the fastest at the bottom. It always has the most height at the top. Haley, hush. I don't care. Stop talking. If you take it or stuff, you decide. Not lead, cars. Oh. You're exactly right. Plastic and carbon. It's not gonna taste very good, but it's not gonna kill you. Now, so if we label these circles 1, 2, and 3, where would the maximum potential energy be? Maximum potential energy has the most height. It's always at the top. Where would the maximum potential energy be? Maximum potential energy is always at the top. All right? Maximum kinetic energy is always going to be at the bottom because that's where the object has gone the fastest. It's picked up the most speed. So maximum KE is going to be down here. Now, if you have to do the minimums are the exact opposite. Okay? Says KE. The minimum Lewis or John, whoever's tapping on the desk, stop. The minimums are the opposite. So if they ask you for a minimum, it's the exact opposite. So if they say, what's the minimum kinetic energy? Okay, the minimum kinetic energy is going to be the opposite. So maximum is here. Minimum has to be where? Up here. Okay? If they ask for the minimum potential energy, it's where? Way down here. All right? Max is at the top for potential energy, right? So if they say minimum potential energy, it's the opposite. So where's minimum potential energy? It's the opposite, so it's at the bottom. Minimums are the opposite. Now, the other thing you have to understand is what happens to it as it goes down. So what happens to kinetic energy as it goes down? What happens to kinetic energy as the ball rolls down the hill? What? It increases. All right. Why does it increase? It's the right answer.
It's going down here.
What's happening to its velocity or speed? That's right. Kinetic energy increases because it's going faster. Okay? Kinetic energy increases going down because it's going faster. Well, I'm just saying as you go down. It doesn't have anything to do with number 2. I'm just saying as you go down the hill. Okay? I'm just talking about as you go down the hill. Not necessarily number 2. Now, what could you tell me about potential energy as you go down the hill? It goes slower. All right, potential energy decreases. All right, tell me why potential energy decreases as we go down. Potential energy has nothing to do about still. Okay, it has less height. Okay, potential energy decreases because it has less height. What? Now,
I told you it was H-E-I.
I don't care.
You said H-I.
Wrong.
I said it correct.
now, does everybody have what they need? Because we're going to change the picture.
No.
Wait.
I'm not going to wait long.
Hey.
I'm never.
All right, does everybody have what they want?
Less height.
All right. So let's say that we throw a basketball up into the basketball hoop. I know, it looks pretty bad.
Hey.
All right, we've got 1 through 6 positions with the basketball. Can't I'm going to need you to move someplace else. You can pick that far back chair back there beside Drew. and I really don't care if you can see or not. But you can't sit there and be quiet. Even Abigail has done better today.
Okay.
I don't care. She's quieter, which is what counts. But you have done very little besides socialize.
What is that?
Yeah, you.
Oh, you didn't even know you was talking about that.
Now, looking at 1 through 6, where would I find the most, look at the potential, where is the greatest potential energy in the picture? No. No. You stop yelling. Where is the greatest potential energy based on what we just talked about? Alright. The most or maximum potential energy as at 4 because you're looking for the greatest height. Okay? Now, you're going to have to measure these or find numbers that go with them on the roller coasters on the lab Monday. You're going to have to find matching numbers on the simulation. Does everybody understand how to find most potential energy? All right. Where is the most kinetic energy?
And 4.
I said kinetic.
5, 6. Good.
Maximum kinetic is always where?
Oh.
It's always at the bottom.
Oh, not my fault.
Okay? Kinetic is always the greatest at the absolute bottom. It's never the greatest midway. It's always at the bottom. Okay? Carlos, pay attention. Now, what happens as we go up? There's 2 answers that you could tell me that would be correct. What would be correct? What increases? You got to tell me what.
The K increases and the D decreases, right?
What?
All right? No. Something does increase. But you got to tell me what increases.
2. Oh, no. Hey, the energy.
The energy.
You got to tell me which energies increase.
Kinetic.
The potential and
What increasing? The height or the speed?
Oh, see.
Think about it. When you throw a ball up, does the ball go faster or slower when you throw it up in the air?
Oh.
It goes slower.
When you press launch,
Guys, y'all have all done this before. We are not getting balls out. We are not throwing them around. Y'all are 11th graders. You have all done this. When you throw something up in the air, it is going to slow down. When it gets up to a certain point, it's going to stop for a second, and then it's going to do what? Drop back down. So as it goes up, it slows down, and as it starts to fall, it does what? It speeds up. Now, based on that, you should be able to tell me what happens to kinetic energy. So as I go up, the kinetic energy has to do what if it slows down?
decrease.
That's right. Kinetic energy has to decrease if I slow down. Now, what's happening to the ball? Are they going more height or less height? More height. So if they're getting more height, what happens to their potential energy? Forget the facts. Potential energy. Guys, potential energy is about height. Okay? So all I'm asking about is the ball higher or lower?
Higher.
So is potential energy greater or less? So does potential energy increase or decrease? Potential energy increases because it's higher. Okay? So, if we talk about this side, what's the ball doing on this side? It's going down. Don't you hit the back, hush. So, if it's going down, it's speeding up. So, what's happening to kinetic energy if it speeds up? Is it increasing or decreasing? It's increasing.
I heard somebody.
So kinetic energy increases. Now, what's happening to the height?
Oh.
It's decreasing. So potential energy decreases. Okay? Now, we need to try one more. God help us all. Yes?
One more.
It's like a swing.
Yes, one more, I need one.
Should have been in class.
At some point, Jeremiah, put it on my desk. At some point, y'all have all been on an elementary swing set. No, the one you had the first time on my desk. No, it's not.
The one I use.
You put both of them on my desk.
I wasn't even on the other one.
Now, so 1 through 5. Okay? We're on a swing set. We're swinging back and forth. Maybe you got a friend who's nice and they're pushing you back and forth on the swing set. Okay? Where do we have the greatest potential energy? Only one?
1 and 5.
Okay.
5, 8.
So the most potential energy is at 1 and 5. All right? Where's the most kinetic energy?
3.
All right? I hear 2, 4, and 3. Where is the most kinetic energy always at? At the bottom. So who's at the bottom?
3.
All right. Last thing we want to do. What happens when we go down? What decreases? All right. So potential. Hush. Kaylee. On Monday, I don't know where I'm going to stick you, but you will be either sitting that far back or that far back, but you will not be there. It doesn't matter. Yes, you can be there too. Your chair, that book bag does not get a chair.
It's a whole lot.
It doesn't matter. No. No, it's not. No. 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 Because I said so. No. Now, on Monday, you're going to have to do this with a laugh. I'm picking the partners Monday.
No, I'm not.
Oh my God.